Thank you for introducing me. And as you know, conotruncal anomalies are very important congenital heart disease. So echo is very important to diagnose. But today, unfortunately, we have only 50 minutes. It's quite short to describe echo in conotruncal anomalies.
Yeah.
So definition you already know. And today, because of short time, conotruncal anomalies major principle is our flow track anomalies. So echo also should focus on the anatomy of our flow track. So today, tetralogy follow, DORV, and TGA. You recently enjoy shorts in YouTube, right? So I will share key images in shorts with you today. Let's get started. Key anatomic feature of tetralogy is enterocephalic deviation of coronal septum. Is the key point, and large VSD here, and septoparietal trabeculation hypertrophy, squeezed RVOT, and various degrees of hypoplasia or dysplasia of pulmonary artery systems. So by echo, this is the key image of subcostal RAO image here. Again, like this specimen, subcostal RA view here, aortic valve, large VSD here, deviated coronal septum, and septoparietal trabeculation, and squeezed alveolar flow track. In this view, also we can see the right pulmonary artery here. From this one image, we can diagnose tetralogy follow, okay? Another patient, the same, large VSD, aortic valve, small pulmonary valve, and deviated coronal septum, and hypertrophied septoparietal trabeculations, and squeezed alveoli. This patient has a little bit good pulmonary artery system, but long infundibular stenosis. And another key image I'd like to show is the subcostal short axis view, LV, RV, this is VSD. You can also notify the enterocephalite deviated coronal septum and infundibular stenosis and small pulmonary artery, and zoom up, okay. Coronal septum here, infundibular stenosis, enteromalaligned VSD, and from this view, we can also see left pulmonary artery. These two key views are important to diagnose tetralogy. Again, parietal long axis view, you can notify the overriding of aorta, large VSD. Also, subcostal view, you can notify the large VSD and overriding of the aorta. This is the muscular septum. These are tetralogy follow. And our flow track parietal short axis view also notify the deviated coronal septum, squeezed alveoli, small pulmonary artery, and in this case, supravalvular stenosis also. So our flow track anatomy and pulmonary system anatomy is very important in tetralogy. You can try to define the pulmonary valve morphology, but it's not easy. So don't waste too much time. Surgeon will not notice them. And the important thing is the size of a pulmonary valve annulus is very important to preserve our transannular patch closure, patch reconstruction alveolar flow track. So the pulmonary valve size measurement is the most important thing in tetralogy follow. And the branch pulmonary artery, tetralogy follow is the pulmonary artery system are hypoplastic and abnormal. So this is very important. In this case, left pulmonary arteries are very diffusely hypoplastic, and actually this patient needs balloon angioplasty after total repair, a month later. And lastly, in tetralogy follow, some patient has the coronary artery crossing alveoli. So in this case, the single coronary artery from left coronary sinus and right coronary artery crossing the alveolar flow tract. This is pulmonary truncal, pulmonary valve, and you can see the clot flow in this. So sometimes left anterior descending, sometimes the right coronary artery crossing alveolar flow tract. When we need to transolunar patch, it's very important to identify the coronary artery anomaly. In pulmonary atresia, the basic intracardiac anatomy is similar to the tetralogy, and importantly, in this case, to identify the pulmonary artery system anatomy and the cause of the ductus arteriosus for initial palliation, shunt or PDA stenting or early repair. But also, this anatomy can be identified well by CT angiography. And next to our right ventricle, you all know that the majority of overriding valve attached to the right ventricle, these are double-rounded right ventricle, and the conceptual cartoon shows the LV and RV, two great arteries arise from the right ventricle, and the relation of the VSD, in this case, and to the great artery, our flow check is very important to type DRV and no hemodynamics. And common variants are as following. Then this is a large VSD, coronary septum and aortic valve, and squeezed outflow track. Notify the relative relationship between the coronary septum, VSD, and rims of septomarginal trabeculation. In this case, coronary septum insert to the anterior rim of the TSM, and VSD is within the limbs and committed to the aorta, subaortic VSD, VS type DRV. In this case also, the VS is within the limbs of TSM, and the coronary septum inserted to the anterior limb of TSM. And in this case, RVOT is wide patent. But in this case, you know the coronary septum here, VSD is here, and pulmonary valve, aortic valve, coronary septum inserted to the posterior rim of the TSM. These are the subpulmonary VSD, so-called the tossing anomaly. And this is the remote or non-committed VSD. Typically, the VSD is inlet VSD with URV, the inlet VSD, or muscular trabecular VSD is the remote or non-committed VSD, and the other type is doubly committed. Yes, this case one is the LV, aortic valve, a little bit far from the VSD here, overriding to the RV, and this view also shows the RV is overridden to the right, and you can notify some distance between the mitral valve and the aortic valve leaflet. There's no fibrous continuity between the aorta, aortic valve, and mitral valve. Okay. Again, other view, you can see small coronary septum and wide paint alveoli. The VSD is here. VSD is committed to the aortic valve. So the DRV with subaortic VSD. VS type DRV. Again, you can see the overrided aorta and some distance between the aortic valve and mitral valve leaflet. Again, DORV, double on the right ventricle. And short axis view shows the wide patent RV flow tract. So VSD, just the hemodynamic, this is the large VSD. Okay. The second case again, you can LV overrided aorta here, and LV outflow tract, Also, you can notify some distance between mitral valve anterior leaflet and aortic valve. There's no fibrous continuity here. And again, longest view showed the aortic valve, mitral valve hinge point is here. There is some distance. Hemodynamically, this is just like large VSD, the VS-type DLV. And doubly committed, again, LV, aortic valve is connected to the right ventricle. Large VSD, LV are follow track. Again, RAO subcostal view showing aortic valve and pulmonary valve. There is no corner septum in this case, so the VSD is doubly committed. So doubly committed DORV, the great artery is overridden again, interventricular septum, but mostly connected to the right ventricle. In rare completed case, you can see big pulmonary trunk, small aortic valve, and there is no corner septum. There is a VSD here. Most blood flow to the pulmonary trunk. Very hypoplastic aortic valve here, and very scanty. In this case, mostly associated with the severe coag or interrupted aortic arch. So another also showed a large pulmonary trunk, small aortic valve. Aortic valve morphology is nearly normal, but the annulus is very small. This is a big ductus. This is left circulating artery, and this is left common carotid artery. Type B interruption. This is the DORV, doubly committed VSD with type B interrupted aortic arch. Arch anomaly can be well identified by the CT angiography here. Next, follow type DORV is subaortic VSD with outflow tract obstruction. You can also notify the overridden or attached to the RV, the aorta is. And blood flow is here. And again, longest view, aorta is overridden more than 50%. And there is some distance between mitral valve and aortic valve leaflets, also double outlet, right ventricle. RAO view showing typical feature of tetralogy, deviated corner septum, hypertrophied septoparietal trabeculations, and squeezed RV outflow tract here. And zoom up, the outflow structure is very important in every conotruncal anomalies here. You can notify the infundibulous stenosis is not severe, but in this case, the valvular stenosis is very severe. This is the follow type DORV. Another case is also RV, aorta is attached to the RV. And again, longest view showing aorta is attached to mostly right ventricle here. And RAO view showing that RV outflow tract. In this case, also there is no corner septum. Tetralogy follow type DORV with doubly committed VSD or subarterial VSD in this case. The infundibulum is not so narrowed, but in this case, the valvular stenosis was very severe. So this patient had balloon valvuloplasty after a few days after birth because of severe cyanosis. Very good candidate for intervention. Now, this case is LV, right ventricle, and two great arteries rise from the right ventricle. Actually, this valve is pulmonary valve. This valve is aortic valve. Aorta is the right side to the pulmonary valve, and the VSD is committed to pulmonary valve. Color flow mapping showing the hemodynamics, most LV outflow tract flow to the pulmonary valve, and RV to aorta. This is the hemodynamically transposition of the great arteries. This is a TGA type DLV, so-called tossing anomaly. Also, parasternal view shows that big pulmonary valve and right anterior aortic valve. VSD is here, and VSD committed to the pulmonary valve. So, double on the right ventricle with third pulmonary VSD. So this view shows the size discrepancy between the valve. In tossing anomaly, usually the pulmonary trunk is very big. Next case is LV, again, very big pulmonary trunk. VSD is here, so pulmonary position. In this case, the coronal septum is deviated to the right. Tossing anomaly, this association is not uncommon, so very careful to watch subpulmonary area in tossing anomaly. In this case, coronal septum deviated to the subaortic area and subaortic stenosis here. You can also notify the color flow mapping here, big pulmonary trunk, small aortic valve, and deviated coronal septum here, and subaortic stenosis. Parasternal longitudinal view showing big pulmonary trunk and attached to the RV, but in this case, there is a fibrous discontinuity between mitral valve and pulmonary valve, but the overriding is very severe, so also this is the double on the right ventricle. And again, very important thing in tossing anomaly is the subaortic anatomy. Small pulmonary aortic valve and subaortic stenosis, anterior or sub-deviated to subaortic area of the coronal septum, and small ascending aorta. Again, big size discrepancy between pulmonary trunk and aorta. And again, by echo, you can find the type B, interrupted aortic arch. And this is ascending aorta hypoplastic, and the left subclavian artery smoothly rising to the subclavian, and this is the descending or ductus flow. So this is the very important cases of tossing anomaly, subaortic stenosis, and type B interruption. And again, in dual with the important thing is another is the AV valve straddling. So in this case, a double on the right ventricle, well-balanced ventricle, but VS is very big and extended extensively to the inner portion, and you can notify the tension of the peritus tract valve is attached to the ventricular crest or slide left side. This is type A straddling of AV valve. And again, the oblique view showing that this is interventricular septum, some part of aortic valve, and stenotic pulmonary valve. Again, the mitral valve tension apparatus inserted to the right side of the interventricular septum. This is the same patient. So this mitral valve is type B, straddling of mitral valve. And in parasternal view showing that there's the inner part of VSD, aorta far from the VSD. This is stenotic pulmonary valve. And again, you can notify the straddling of mitral valve tension apparatus. In this case, the biventral repair is usually not possible, but sometimes you can. This is another case of tossing anomaly, also very extension to the inner part, mitral valve tension apparatus to attach to the right ventricular structure, maybe the moderate band. And again, longest view showing the tension apparatus inserted to the right ventricular structure. This is severe straddling, and this is the type C, AV valve straddling. Another rare case is you can notify two great valves attached to the right ventricle. Actually, the VSD is the subpulmonary, but VSD is very small. And also there is a subvalvular pulmonary stenosis. This is a very rare case of restrictive VSD. So in this case, it's not easy to do biventricular repair. So this patient also content operation. And again, in this case, because of small VSD, LV pressure is very high. So you can notify the white change of papillary muscle, ischemic change of mitral valve apparatus. So there is some MR. This is a long-term concern in this patient. And lastly, transverse great artery is very simple. Diagnosis is very easy to diagnose TGA. Atrioventricular discordance, concordance, and VA discordance you can see. RV to aorta, LV to pulmonary artery. Also, you should notify that the great artery gives rise to systemic branch. This is aorta, and bifurcation to the both lung is pulmonary artery. And this longest view showing typical case of TGA intact ventricular septum. And again, associated anomalies, the VS is most common, and you can notify the existence of VSD and the direction of the flow. So in this parallel circulation in TGA, the mixing between the two circulation very important just after birth. So this is VSD, bidirectional shunt. And another associated important anomaly is LVOT flow track. You should identify the existence of LVOT obstruction. The substrate of obstruction is very various.
We are correct behind the schedule.
Okay.
Yeah, thank you.
Just, and the coronal anomaly is very important. You can describe coronal anomaly in systemically the modified Leiden convention. You all know that the facing sinus here is pulmonary trunk. Right-hand facing sinus is sinus 1, and left-hand facing sinus is sinus 2. So describing the coronary artery origin as branching pattern, the start sinus 1, in this case, R, sinus 1, R, dash means different sinus, and 2 from L, CX, counterclockwise, stepwise description. And in this case, the same sinus, 1, R, and L, but different orifice, describe comma, and different sinus, dash, and 2, CX, and other associated conditions for coronary arteries. And lastly, the mixing condition assessment is very important. This is very restrictive interatrial communication and very small PDA suffering from severe cyanosis, just needed emergency balloon natural septostomy. And in this case, the PDA is big and bidirectional shunt, the mixing is okay at this time. And this view, you notice the AV valve morphology, commissural alignment, and relative relationship of the great artery and size. And then, thank you for your attention.